right, good afternoon, everyone. We're going to be starting Unit 2 with graphing trig functions, but we're going to be doing a lot of seeing that connection between unit circle and our graph of sine and cosine. So if you guys can get out your unit circle filled out sheet, as well as the calculator, and we're going to be kind of transitioning from unit circle and looking at it from a graphical perspective. Okay, so just a little bit of a preview into our unit. We're going to be looking at sine and cosine graphs, seeing similarities, but then also differences. We'll explore some more sine and cosine tomorrow in terms of amplitude, and review Monday, and then we're just going to have a short quiz on Tuesday. It'll be a check-in quiz. We'll have the first 10-15 minutes to review, and then we'll take that quiz, and then we can start our next section. So we're going to kind of have these, multiple quizzes along the way, just to make sure that we are understanding each section. And then we're going to have our tests near the end of our end of this month. And right now we're still discussing some application quiz as well. But we're going to have these, these check-in quizzes along the way over the course of this unit. Okay. So if you guys can have your unit circle sheet out. Now what we're going to do is we're going to be exploring sine values on the graph. So we're going to be treating our radian measure as our x values on a coordinate plane. And we're going to start off with the y values. So we're going to be graphing all these y values and seeing the pattern across our graph. We're going to see that it's going to kind of resemble kind of a wave-like shape. And same with sine and cosine. So I'm just going to start us off, and then you guys will be able to kind of build the rest of it using your unit circle and using the pattern that I'm going to kind of help you get started with. So first, we're going to identify the appropriate radian measures for each of the corresponding degrees. So we know 0 degrees matches with 0 radians. 30 degrees is pi over 6, pi over 4, pi over 3. Okay, so I'm going to kind of do this first part with you, and then you guys will extend using the pattern that we're going to see here. So for each of, so we're going to find sine of 0, sine of pi over 6, sine of pi over 4. These are all y values along our unit circle. So I'm just going to copy them down here. So we know sine of 0 is going to be 0. Sine of pi over 6, 1/2. Sine of pi over 4. And then sine of pi over 3. And sine of pi over 2 is going to be 1. To make it easier, so that we know where these y values are, we're going to enter them in the calculator. So 1/2, is 0.5. If you type in root 2 over 2, you see how it doesn't, if you're using 36 Pro, it doesn't give you a decimal value. What you can do, though, is you can go to the bottom. You see right above that enter button, there's that fractional decimal button. If you hit that button, it'll give you a decimal value. Okay, so 0.707 is the decimal equivalent of root 2 over 2. Do the same thing with root 3 over 2. And these are decimals you're going to see over and over again. So eventually you're just going to associate 0.707 with root 2 over 2. and then 0.866 with √3/2. These are, you're going to see these decimals over and over again. So eventually you're just going to recognize them. Okay, so I'm going to take, think of your radian as your x value. This is your x value. And then think of your sine, exact and decimal. These are your y values on your coordinate plane. Okay. So we see that these are all increments with the radian measures that we're going to identify. So the middle one here, pi, this is pi/2. And then all the increments that are clumped together, those are pi/6, pi/4, and pi/3. So I'm just going to kind of start us off, and then you guys will continue to see if you can finish it. So we know at 0, my y value is 0, so 0, 0. At pi/6, my y value is 0.5. At pi/4, my y value is 0.707, so I'll just pick a point that's somewhere between 0.5 and 1. 0.866 is for pi/3, so just make our best estimation between 0.7 and 1. And then sine the pi/2 as well. Okay. So continue on with the rest of the graph. You're going to extend all the way to 2 pi, so your graph is going to end here. But then you can kind of follow the pattern. It's going to repeat the pattern again, and you can follow that pattern and see if you can use that pattern to build out your graph from 2 pi to 4 pi. But it's basically just a repetition from what you see from 0 to 2 pi. Okay, so try that. Let me know. I'll walk around to see if you guys have any questions or if you're having any trouble.
We're just going to 360.
Huh? Yeah, we're going to go all the way to 2 pi, which is, yeah, basically 360. But on our graph, we're going to think in terms of radians and not so much degrees.
Not going to be enough room.
Okay, let me see.
Like, it's going to go over one.
Well, I think it's going to start from the zero line because at 120, which is at 2/3, see your 2, so that goes back down. It's never going to get it. It's going to keep going.
I know.
Are we doing the graph or the chart?
You can I did the chart, I did the chart then the graph, so now you can go back to the chart. As you're doing kind of transition to the graph as well.
Yeah.
I mean, basically, yeah, you just talk about all the y values. That's right, yeah. This negative is going to be below the x line. Oh, below the x line.
So the decimal is always going to be 0.866.
I mean, if it's √2/2, it'll be
Like
0.7.
3, yeah.
And then √2/2 is always going to
It
be.
will always be those 3, though.
Pretty much, yeah. It's always going to revolve around these decimal values and 0 and 1. But then there's also negatives too. So part of your graph is going to dip below the x-axis. So right now we're kind of doing all the little details. Later on, we're just going to pick off the most important points and graph it. We're not going to look at every detail, but right now I want us to see that connection with unit circle values and our graph, right? That they're all going to line up nicely along our curve. And then once you reach 2 pi, you're going to you would have completed a full cycle for your sine curve. But look at your order pairs from 0 to 2 pi, see if you can copy those values down, and you're going to create the same pattern from 2 pi to 4 pi. So your graph should kind of look like mine. Your y values will become negative. If you look at all your third and fourth quadrant y values, right, those are all negative versions of the decimals that you have from first and second quadrant. So that's going to create that that portion that sits below the below the x-axis. Oh, okay. So 2 times 3, we're looking at the y. So it's not going to hit the negative. So we will look at the x values and go to the cosine graph on the back page. But right now we're just looking at the y values on your unit circle. Okay, some of you guys maybe still be working through your chart and your curve, but I'm gonna see if we can kind of move on to talking about the graph in general. So we see that the graph kind of has a wave-like shape, right? We start at 0. Sine graph is going to start at 0 and it's going to rise to that maximum value, and then it's going to start its descent down all the way to the minimum value, and it's going to come back up to the x-axis. Okay. So it starts and ends at the same place. That's how we know that we kind of reached our full pattern, because after this, it's going to start up again and do the same thing and complete its cycle within 2 pi. So we call this one period. Okay. It's the full cycle for our sine graph. So if you guys can highlight those items. We can point at the maximum. We can also point at the minimum, the lowest value. We're going to see a lot of similarities between sine and cosine. So if you guys can just write a little note here that your sine starts at 0. Okay, sine starts at 0, and then we start our pattern. Okay, so let's look at some of these properties of our graph here. Okay. Period is the distance required for our graph to complete one full cycle. So we see that our period is going to be 2 pi. Because after it reaches 2 pi, it's going to start, the cycle is going to repeat again. It's also the length of our cycle. Okay. Second is domain. Domain is the set of all possible input values. So it's basically all the x values. This curve is going to extend indefinitely in both directions. So if we go into the negative region, it'll just continue. We can continue plotting infinitely the same pattern, whether we move left or right. So what do you think the domain is? Okay. There are no breaks in the graph. It's all real numbers, right? So we say negative to positive infinity. And then you can also use the notation, this double vertical line with the uppercase R to represent all real numbers. So domain of a function is a set of all possible input values. Okay. And then next is the range. The range is the set of all possible output values. So you want to explore the lowest to the highest y value, which is what? Lowest is -1, highest is +1. The difference is that now we got to use brackets because we're actually going to reach those values. So we say bracket from -1 to 1. Okay. All right, number 4, x-intercepts. X-intercepts, where do you see x-intercepts? Okay, 0, where else? Pi, 2 pi. So there's that pattern, right? So basically all increments of pi, whether in a negative or positive direction, we're going to hit all these x-intercepts. So basically we can say all multiples of pi So it can be, negative pi, -2 pi, -3 pi, or it could be in the positive direction, 3 pi, 4 pi, 5 pi. But the way that we can write this, where we can indicate that we want all multiples of pi in a more concrete way, is we write it this way. We say pi n. And n is just, we're going to represent n as an integer. So n can represent any positive or negative integer. So we want to indicate that by saying n is an integer. And we have a notation for integer. It's like this z looking notation. And then e just represents that it's an element. It's part of, n is a part of is defined as an integer. So we want to just make sure that we're not just thinking of n as a decimal value, that it's a very specific, restricted to just integers. All right, what about y-intercept? Where do you see a y-intercept on our graph? Just 0, right? It doesn't touch the y-axis anywhere else except at 0. So okay, what is the maximum value? 1. Okay, and where do you see occurrences of the maximum? Pi over 2, and what's the next one going to be?
2.5 pi.
Yeah, so it's going to be increments of 2 pi, right? Either in a positive or negative direction. So we can think of it as, if I just keep adding 2 pi or subtracting 2 pi, I can keep hitting the maximum in both directions. So we're going to use a similar notation here. We're going to say x equals pi over 2, and then we're going to extend in both directions, either add or subtract 2 pi. So we say plus 2 pi n, and n can represent either positive or negative numbers. So we say n is an element of an integer. That we're exclusively just using integers to represent n, and that way we can have a definition for all the locations where the maximum can be reached. Okay, so basically it says every interval of pi over 2, or starting at pi over 2, if we keep incrementing by either 2 pi or negative 2 pi, we're going to hit all the max and hit all the max. Okay, minimum value is -1. And where do you see -1? Yeah. So similar notation. It's just that we're now starting at 3 pi over 2 and we're incrementing by 2 pi in both directions. Okay, any questions? Okay, does anybody still need to look at this page? Okay. I guess okay. There's one more thing I want to point out before we flip the page, is we are, going to just from now on, we're just going to focus at the kind of like the big important points. It kind of helps us if we just know where the important points are. We can just kind of have those max and mins as starting points, and then we can sketch the graph a lot easier from here on out. We're going to be stretching, moving our graphs all the way around, so we're just always going to be targeting 5 points to create our graph, rather than all those intermediate points. Because if we know the starting points, heights, and lowest points, then we can kind of piece the puzzle together. So if you guys can highlight basically just the quadrant values, these are the ones that are the easiest to plot, and it's also the ones that are at the extremes and at the beginnings and ends. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the values that will be the easiest ones to plot and easiest ones to kind of give us an outline of our graph. Okay. So I'll leave this up here in case you guys still need to look at it, but now we're going to transition to the second page. And very much like how you did with the sine graph, now you're going to create order pairs for the cosine graph. The difference is that now, instead of looking at the y value of your unit circle, you're going to look at the x value of your unit circle. Those will be where you're going to start filling in the second and third row for your cosine values. Okay. Okay, so let's look to the second page. Okay, in much the same way, your radians will be aligned with what we're looking at, but now instead of pulling the sine y values of your unit circle, now you're going to target the x values of your unit circle. Now we're going to be looking at the behavior of the cosine graph along the curve. So let me just start us off. Notice how the cosine starts in a different location than the sine graph, right? Sine graph starts at 0, but your cosine is actually going to start at the peak of your graph, of the height of your graph, and then take its way down.
All the radians are the same, right?
That's right. All the radians are the same. Once you fill out your chart, once you fill out your graph, you should be able to use what we did on the first page and identify all those properties in a very similar form. So you're going to see that everything from the first page in terms of x-intercept, max, and mins are going to be slightly staggered from what you experienced with the sine graph. So once you go all the way to 2 pi, you're going to see that the graph is going to be complete, and then you can copy that cycle again from 2 pi to 4 pi.
It's just going to reverse, right? Starting at 1.
Yeah, starting at 1 and going down.
decimals being different?
Decimals are the same. Only decimals you're working with is 5.7, 0.866.
7%.
See if you're able to fill out the properties, much like how we did on the first page. Just it's hitting the max and mins and x-intercept at a different point, so we just have to adjust that when we state our intervals.
The negatives are different on the decimals. The negatives are different.
So we see that the max is still at a 1, the min is still at a -1, our period is still 2 pi, domain is the same, range is the same. It starts at a different spot, and something that may help from a visual perspective is think of cosine resembling a cup. So if you can kind of just think of it from 0 to pi, kind of has that cup shape about it, and so maybe that will kind of help you remember the distinction between cosine and sine. They're basically the same curves, they're just kind of a little bit off in terms of their starting points. So, but they're following the same path, and they're having the same shape as well. Okay, so let's go down each of these values that they have written down here. Period is still what? Still 2 pi. Domain. Yeah, still all real numbers. Okay. Range. Still no change, -1 to 1. And x-intercept. It's not going to be it's not increments of pi right now. It's going to be what? Yeah, so pi over 2 plus pi n, right? So it looks like it's hitting the x-intercept more than once within a cycle, right? Hits it twice every time, so it's going to be plus pi n, n being an element of an integer. Okay, y-intercept is 1. Okay, not 0 like the sine graph. It's going to be 1 for the cosine. Maximum value is 1. And where do you see the max value occurring? Yeah, starting at 0, right? So 0 plus 2 pi n. So starting at 0, we just keep moving 2 pi to the left or to the right. We're going to keep seeing all those max values reached. Okay, minimum value, -1. Yes.
For 6, could you say multiple to 2 times?
Yes, it's multiples of 2 pi, but this 2 pi n is, I guess it's a more mathematical way of writing it, but yeah, I think we're going to prefer that you write it in this form. Okay. Oh, all right. What about minimum value? So minimum value, we start at pi and we say what? Pi plus 2 pi n. No. Okay. Much like the sine graph, we're from moving forward, we're just going to be focused on the 5 most important points so that we can get the peaks and valleys and the ends and the starting point. So you can highlight your quadrant values again. 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are the ones that we're going to be focused on. All the other middle values, we can just kind of connect the dots and kind of have a feel where those are going to lie. Okay, does anybody still need to look at 1 through 7? Okay, let's see, there's a couple things I just want to point out here. Okay, I was trying to point something out here. What I did is, in yellow, I highlighted this path and the cycle for our cosine graph. Okay, so I know cosine graph, we can start at 0, but same thing here, right? Start at the highest point, moves down. So it's the same cycle from 2 pi to 4 pi. I wanted to highlight that because I also wanted to show that this similarity, but also distinction with the sine graph. And sine graph, I have it in orange. So what would you say that relationship is between sine and cosine? They follow the same path, basically, right? But we can kind of see that the cosine kind of has a delayed start, right? So let's say sine starts at 0, goes up, then goes down. So basically, pi over 2, right? 1/2 pi into the start of the sine is where cosine begins, right? And then cosine just follows the path of the sine, but it just, it has a different start. It starts at a different value, but it's basically going to pick up halfway or a portion into the sine graph and then follow it along. So basically what I want to say is that your sine and your cosine are basically staggered by pi over 2. Okay, and we're going to see that relationship where sometimes we can create a sine graph by just taking a cosine graph and then just shifting it, okay? Or vice versa, right? I can create a cosine graph by taking a sine graph and shifting it as well. Okay. You can also see by comparing your max values, right? Your max values, 0 plus 2 pi k versus pi over 2 plus 2 pi k. And then even the max and min values are also off by pi over 2. Okay. Okay, so let's see if we can do a little bit into a little bit into the next page. And we're going to practice just identifying those quadrant values of sine and cosine, just to make it easier for our graphing in the future. We just want the highlights. Okay. So remember the pattern and the shape of graph for sine and cosine function. So for theta, we just want the quadrant values. It's always just going to be 5 points. If we can identify the 5 points for sine, cosine, all the trig functions, it'll kind of give us a good feel for how the rest of the graph looks. So The most important theta values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So right, we know sine kind of starts at 0, then it moves up to its max, comes back down, goes down to its minimum, and then comes back up to the starting point. Okay, so let's practice graphing those. So I'm going to have tick marks there. So 1, 2, 3, 4, 5. And I'm just going to start graphing them. So I'm going to pick a point 1 and -1. Sine goes up to its max, comes down to the starting x-axis, down to its minimum, and then back up to the starting point. So there's my sine graph, a rough sketch. Let's repeat that process on the negative side of things, so we can practice going in the other direction as well. Also, 5 points. We're going to include the origin as a point. So 1, 2, 3, 4, 5. And we're just going to extend the pattern over to the negative side. Okay, see if you guys can do cosine. Once you graph your cosine on the positive side, see if you can extend it to the negative side. Okay, cosine starts at its highest point, and it's going to start making its way to its lowest point, and it's going to end up at its highest point. So it resembles kind of a cup. Okay, questions? Okay, one final thing. We're going to explore this a lot more, but just an intro is we're going to talk about amplitude. Okay. So amplitude is basically going to do the job of stretching the graph vertically, and it's going to be imagining stretching or compressing the graph vertically. And if I multiply a coefficient in front of my parent graphs, my sine and cosine, it's going to end up stretching, and it's going to change the heights of my graph. So amplitude is your A value, basically that coefficient in front of, it could be 2, it could be 3, it could be 5 right now. We don't necessarily see a coefficient. Okay, so here's the definition here. Amplitude is the distance from, quote unquote, the center of your graph to the max height. Okay, so if you look at the sine graph, right, the sine graph, if you look at the sine graph, you can think of the 0 as the center, right? It's kind of like the center of your graph. What is that distance from the center to the max height? 1, right? So that's our amplitude. That's our amplitude. Also, if you look at the sine function, what is the hidden number in front of sine? 1. So that's the amplitude. Amplitude is 1, and we can see it demonstrated in our graph. Right now, our parent graph has an amplitude of 1. So we identify the center, and then we just find that distance from the center to the highest point. Or you can go from the center to the lowest point. Either way, we're going to be consistent. It's just going to be a distance of 1. Okay. Another way that I've seen people say is they say from rest to crest. So another way of saying from the center to the highest point. Okay, any questions? So tomorrow we're going to dig a little deeper with amplitude, identifying how to graph if there's a different amplitude involved. Okay, no homework tonight. We're just going to pick up where we left off tomorrow.